Saxon Advanced Mathematics, Lesson 16. Well, after wrestling with proofs last time, and postulates of congruency and Euclidean, I can't even think of all the words of it, the Euclidean business, right? The 10 different postulates. We're gonna just step back into algebra land and stand on solid ground. We're gonna review 3 different topics. The first one is complex fractions. We have 2 examples to work through. 16.1. Simplify. Remember, the very definition of a complex fraction is that we have more than one division bar, and our goal is to get it down to just one. It's letters. We're never going to find a numeric solution, but we can make all the extra bars go away. Remember that we go to the most complicated part of the denominator first, and that's where we will start. And remember, our strategy is to smush and flip. And I'll explain what that means. Those are Evie Jones' immortal words. Here we are down in the basement. We're trying to add these two and make them go away. Remember, if we can turn the denominator into a 1, it goes away. So we want to push these into a single fraction and then use their reciprocal to turn them into a 1 and blast them out of our problem. In order to make these match, in order to add these, the denominators have to match. So I am mentally saying, okay, least common multiples D. I better multiply this one by D over D and then combine them. The way that I do that shorthandy is I multiply the top and then I just make the line flow together to show that they both have a denominator of D. That's a shorthand way that I can do some of the steps in my head, minimize my writing, and now I'm all ready to show me multiplying by the reciprocal. Whoops, that's a plus sign, right? We're multiplying here. Now I have to do that up here as well. Right? This all goes away, turns into a 1, and poof, it's gone. Yay, that's why we start in the denominator. We're trying to turn the denominator into a 1 because that makes it go away and we can kind of work back up through the levels. Now this becomes a little bit tricky because I know this is gone, but what am I doing here? The A stays out of it. We just multiply the numerator of this fraction by that. So I'm going to rewrite the whole thing, x over a plus, and then md over bd plus c, right? I can think of this as being over 1, and I multiply across like that. Okay, good. We've cleaned up one level. Now we're ready to smush and flip again because these are separate, so we have to put them together. Again, I can see that's my least common denominator. I have to multiply this by the same, top and bottom. So what I'm going to do is I'm just going to write BD plus C. That's me multiplying the top. And here's how I show I multiplied the bottom. I just put them together. Now I'm ready to multiply by the reciprocal. BD plus C over A times the quantity, BD plus C, plus MD. It's turning into a lot, isn't it? Quite a lot. All right, I'm multiplying this by the bottom. I also have to multiply the top. So I carefully write the whole monstrous beast over again. And now this all disappears, turns into a 1. Poof. Just like blowing bubbles on a nice summer day, right? 1 minute it's a shimmering bubble floating through the air, and the next thing you know it pops and it's just gone. Okay, now our last step is to multiply this by x. If we want to put it over a 1, sometimes that helps. So I'm going to write it as x times the quantity, BD plus C, all over this. Now I see there's a couple parts I could multiply out. I could distribute if I wanted, but I'm not sure how John's going to show it. So I glance at my solutions manual to see How is he presenting this? I don't really look at the letters. I just look for parentheses and I see, oh, he distributes on the bottom but not on the top. That's a fairly common presentation that mathematicians tend to favor, is distribute downstairs but leave the top plain. So I'm going to go BD plus C quantity, and then I'm going to distribute this out. So it will be ABD plus AC plus MD. Let me make sure that's right. Yay! That's the right answer. If we were taking a test and you gave me the answer in this form, I would not take any points off for it. This is absolutely fine with me. Distribution is never right or wrong. It just is what it is, and you present it however you want it to be. All right? Usually it's whether you distribute or not has to do with what the next step might be, but I would give you full marks on that. Okay, next one. This one is also a complex fraction, but it's got a fairly different form. What's different about this one is that we've got different denominators, so we have to do a little more work to make them match. So again, I start in the basement. I see that my LCM, I'll write it over here, I'm a little squished on the other side, is going to be x squared c, right? So this one I have to multiply by c, and this one I have to multiply by x. Does that make sense? Cx squared, and I multiplied this one by x, so that turns into that. Now I've got the LCM on both, right? So now I can rewrite this as Cm plus Kx over, and I'm going to write it alphabetically, Cx squared. That makes me happier. Now I have to multiply by the reciprocal. Cx squared over, and I'm squishing Cm plus Kx. Look good? Now, I have to do the same thing up here. Cx squared over Cm plus Kx. Now, I could distribute that across the quantity that I have in the numerator, but another option would be, let's go ahead and smush these two and make them into a single fraction, and then we'll multiply as a final step. So I'm going to do that. I'm going to let this wait right here while I add these. Here, my LCM is a little simpler. It's just going to be x squared. So this one's fine, and I just have to turn that into a bx, right? I'm multiplying by x over x. So now I have a plus bx over x squared. And I'm multiplying those two together, right? This is all gone away. The bubble popped. And this is my final answer. This is going to be my final answer. But what I notice is I can cancel this x squared, which is being multiplied by the c. It's okay to cancel when we're multiplying. It's not okay to cancel when we're adding. This x squared and this x squared can go. So my final answer is I take this c, this quantity, all over that denominator. I'm undistributed in the top, but I'm distributed in the bottom, so I feel good. I look at the answer. AC, oh no, John did distribute in the top. Fine, John. I'll distribute and I'll alphabetize. So I can distribute, and this is what I get to, AC plus BXC, same difference, MC plus KX. Okay, again, I would take either one of those as perfectly proper and correct. Distributed, undistributed. Okay, there's a nice review of complex fractions for you. Two different styles. Let's move on to the next section. which is abstract fractions. No, abstract equations, sorry. They involve fractions, but these are sometimes similar to complex fraction problems because there's a whole lot of letters and not many numbers in sight. Our strategy, however, is a bit different. And this time also we have equal signs, right? An equation means it has an equal sign, but our complex fractions did not have equal signs. Solve for y. Now that's an important thing about these abstract equations. With our complex fractions, we knew that we were trying to get the division bars, the extra division bars to go away, right? That was our goal. We were trying to net it down to just a single fraction. With abstract equations, we are a little bit more at loose ends because unless John tells us what to solve for, we don't know what to do. He gives us this expression, y equals it's very confusing because it's a little bitty, it's a v. This is a v. We rarely have v's in the middle of our problems. A over x plus b over mc. Okay? Unless John tells us what to do, we don't know what to do with this. There's no obvious step forward, but he does tell us to solve it for c. Now, if we want to give ourselves a panic attack, we can look and see, oh my God, the c is buried in the denominator inside the parentheses. How in the heck are we going to get it out? My advice to you is don't even worry about where it is at this point. First thing we want to do is distribute and get rid of the denominator. So let's just do that, and then we'll worry about where this c is. So 1, distribute. Let's get rid of the parentheses and kind of open it all up. So we get y equals, I'm going alphabetical, AV over x plus BV over MC. Oh, I feel so much better already. Do you? So much better. 2, blow up the fractions. Get rid of them. Because we have an equation, and there's an equal sign, that means we can totally eliminate them. With expressions that do not have equal signs, the best we can do is just net them down and make them into one little package. But if we have an equal sign, that means we can totally get rid of them. The way that we do that is we find the LCM, which is going to be what? CMX, right? If we put it alphabetical, there's the X and there's the CM. And we multiply every term by the LCM. So CMX, CMX. I always write it at an angle like this so that I'll remember what I'm doing, because it's really easy to get crazy on this. Now we're going to simplify. This side, there's nothing to do, so I'm just going to write CMXY because I like alphabetical. Here we can cancel this x against this x. And we have ACMV, if I go alphabetical, and then plus, and here the MC's cancel, and we have BVX. Okay? That's the whole idea of calculating the LCM and then multiplying each term, is it allows us to cancel our denominators against them. Okay, so now we've got this. Now we pay attention to the letter that we're looking for, and this is the way I write the step. Gather desired variable. What I mean by that is get all of those on one side of the equation and push all the other junk to the other side. So I see a C here and a C here. So I'd say let's subtract this and bring it over here, and then that dude stays over there. CMXY minus ACMV equals BVX. Now here comes the really fun part. Factor out desired variable. So the way we do that is to say, okay, we're going to pull out the C, and we'll have MXY minus AMV, right? I just pulled the C's out of both of these and put it outside. This stays the same. And now, divide away. If we just divide by this, our C will be by itself, and all is well in the world. Now we have to do the same thing over here. MXY minus AMV. This is our answer. And it's because it's so squished there, I'm going to write it over. I don't like to write it over there because these are so complicated, it's easy to just copy wrong. BVX over MXY minus AMV. Let's see if John agrees with us. XVB, okay, I did VBX, over XMY, yes, minus MVA. Different order within each clump, which is fine because that's multiplication, and multiplication order doesn't matter, but this is correct. Yay! There are the steps on that. Complex fractions and abstract equations, most students kind of like, because once you get the hang of them, they're not so bad. And you notice because it's all letters, we're not doing any calculations. We're just shuffling letters all over the place, which most students find to be kind of a pleasant relief. Okay, last step. These two steps, the complex fractions and the abstract equations, we use quite often in upper mathematics, yes. This last one that we're gonna do, dividing polynomials, this is a dead end. We rarely use this process in upper maths. It's more polynomials. It's more of a parlor trick. I was just reviewing it with the Algebra 2 kids, and I told them, you know, if you're ever at a sleepover and your friends are bored, pull it out like a magic trick, you know, say, oh, would you like to, want to see me divide some polynomials? And I'm sure your friends will be delightfully impressed. Okay, last example, 16:4. John tells us, I'm going to write down the way he writes down the problem. He says divide x to the third minus 2 by x minus 1. And then he tells us to check our work, which I think is annoying. But that's okay. Remember that when we divide something by something, this is the number that goes inside the division box, and this is the number that goes outside the division box. Okay? So here's our division box, yay. Now, as I go to write this number inside of it, I realize, oh, we have a problem here, because we have a cubed, but we don't have a squared, and we don't have a plain x, and then it goes all the way down to just a plain number term. So what I do is I add them in by putting a 0 in front of them. They're kind of like placeholders for that place value, right? It's kind of like we use zeros in regular numbers, right? So this will allow us to work our problem smoothly even though we don't have any x squared or x terms. By setting up the zeros, we'll be fine. This goes on the outside. Remember that the 4 steps, I'll write them over here, are estimate, 2, multiply, 3, subtract, 4, bring down. When you learned how to do long division in, I don't know, like 4th grade or something like that, these are the very same steps that you use for just ordinary long division. It's interesting that they work exactly the same with a few slight tweaks, but this is exactly what we're doing for this. We start by estimating. Now the way we estimate is a little bit different. We look only at the first part of the binomial and the first part here. And we say, what do we have to multiply by this to get that? X times x squared would equal x cubed. So that is our estimating, we've got it. Now we multiply. When we multiply, we go back and do that actual multiplication. We get our x third, yay. But then we go ahead and pay attention to the second part of the binomial now, and we would get minus x squared, right? Now we're ready to subtract. please always put parentheses around and the minus sign out front. What that does is it means we're subtracting here and it cancels. Beautiful. This minus turns this into a plus. Make it a plus and then circle it to show I've changed it. Sometimes we'll take a positive and turn it into a minus. Sometimes we'll take a minus and turn it into a plus. But the subtraction always changes the sign of the second part. So change it, circle it to remind yourself I did it, and then go ahead and add or subtract as necessary. Now we have x squared there. Oh, that's not so bad, right? Now we're ready to estimate again. What do we multiply by x to get x squared? Plain x, right? X times x is x squared. Oh, I didn't bring down, sorry. Plus 0x, right? I'm just bringing that down. Our first multiplication, our second, minus x. Subtract. This cancels beautifully. This turns into a plus. So now we have a plain x there. Bring down the minus 2. What do we multiply x to get x? Plus 1, right? So now 1 times x is x. 1 times minus 1 is minus 1. We're subtracting. So this cancels. This becomes a plus. Minus 2 plus 1 is minus 1. What do we multiply by x to get minus 1? That's not going to work. So our answer is minus 1 over that number, x minus 1. Okay, so this is our answer. However, John, let me just make sure it's right. X squared plus x plus 1 minus 1 over x minus 1. Beautiful. Okay. So now what John wants us to do is check our answer. What I'm going to do is I'm going to copy this number and this number to the top of the next page so that I have room to work. Ready? X squared plus x plus 1 minus, right? That was our answer, our quotient. And this was our divisor. It was x minus 1, right? That's what was on the outside. So the first thing we want to do to check our answer is set this part aside, and we're just going to multiply this much of it, right? I'm going to kind of cordon him off. He's in his own little bubble. We'll deal with him later. First, I just want to multiply this, right? So, doing the dance, that's x to the third plus x squared plus x. She's done. Multiply this way. Minus x squared minus x minus 1. Oh, look what happens. That cancels. We get x to the third minus 1. Now we're ready to take this back into account, right? Minus 1 over x minus 1. Now I need to multiply this much times x minus 1 because I've multiplied this much by x minus 1 and I got this, but now I need to take this part and multiply by x minus 1 again, right? We multiplied both parts of our answer by x minus 1. Okay, this is our full answer. and we're multiplying it by x minus 1 to try to get our whole number back again, right? What we started with, which was, by the way, x cubed minus 2. That's what we're trying to recreate, right? So we multiplied this much, and we got this. We're close, but we're not quite there. So now we have to multiply the second part of our answer times x minus 1. And notice these cancel. So when we combine it, there's how we get the x to the third minus 2, which is what our original amount was that we were dividing. So we can check our answers in these. We take our long answer and we multiply it out. And I did it separately because that helps me keep it straight. But we multiplied the first part by minus 1 here, and then we multiplied the second part by minus 1 down here. And we got our answer. Yay! Guess what? That's the end of lesson 16. I hope that didn't burn your brain out too badly. I need you to I need you to be able to function in your life, right? You need to be able to function in your life. Okay, yay, we're done. Enjoy your homework. Goodbye.